So hello everyone and welcome back to a brand new video, and in this video I'll be solving problem D, that is knowledge cards, from round 831. And this problem I think was much easier than problem C, and you guys will realize this as we move along with the solution. Yeah, so let's get into it. Before we move on to the solution, I want to take a small break and tell you guys about Newton School's Premier Coding Contest. So as all of you guys love CP and all of you guys love to code, this is a great opportunity to show off your coding skills and also win some cash prizes. There are prizes worth rupees 30,000, and along with this you can also win some free coding courses or also grab some internship opportunities, right? So for this reason only, Newton School organizes this contest every month on a global scale. So you can also benchmark yourself where you are lacking or where you are standing compared to other students. So this month it will be on 27th October. It will be around 2.5 hours starting from 9 p.m. and it is absolutely free to sign up for. So there will be a link down below. So do check out that link and sign up for the contest for absolutely free. Yeah. So let's move on to the solution now. So in the problem, we have been given a grid of size n into m, where n into m is less than 10 to the power 6, and we have been given a grid of size n into m. Let's say n is equal to 4 and m is also equal to 4 for the time being, so something like this. Right, so we have a grid of size 4 into 4. Along with this, we have been given a permutation of k cards. So we have a permutation of k cards. A1, A2, A3, so on up to AK. And all of these cards are lying in a stack from top to bottom. Right? So if we have a stack, A1 is lying on the top, then A2, then A3, and so on up to AK. We want to move this entire stack of cards from cell 1, so currently this stack is placed at cell 1, 1. We want to move this entire stack of cards from cell 1, 1 to cell n, m, such that the permutation at cell n, m is 1, 2, 3, so on up to k. Right? So we want to form the identity permutation. We want to form identity permutation at cell n, m. So if my stack was A1, A2, so on up to AK at cell 1, 1, at cell n, m it should be 1, 2, 3, so on up to k. This is the permutation that we require at cell n, m. And we have to answer in either yes or no if it's possible to do this or not. So we have to answer in either yes or no if it's possible to do so. So to do this, we have been given some operations and some conditions. So let's move on to that now. So we have been given an operation. In an operation, you can move top card of a stack to adjacent cell. Right? For example, so let's say the stack of cards at cell 1, 1 is A1, A2, A3, A4, so on up to AK. Right? Initially, all other cells are empty, right? So there are empty stacks on all other cells. So we can move the top card. So the top card here is A1. So we can move the top card to any adjacent cell. So I can take this card A1. I can remove this from this stack and I can remove it to any adjacent cell. So let's say I move it to cell 1, 2. So now my card A1 is in this stack, right? I can apply the same operation again. So I can move the top card. The top card of this stack is A1. So I can again take A1 from this and move it to any adjacent cell. So let's say I move it to the bottom cell, right? And I can keep applying this operation again. So that is how I move cards throughout the grid. So you can take any top card of the stack and move it to any adjacent cell. That is the operation. Also, we have been given some conditions. The condition is that you cannot move card back to cell 1, 1. right? So if you take a cell out of the initial stack, so this is my initial stack, right, at cell 1 comma 1. So once you take a card out of this initial stack, you cannot place card back into this, right? So if I have moved out A1, I have moved A1 out of this, right? I moved A1 out of this. I cannot place back A1 into this, right? So once you move a card out of the initial stack, you cannot place a card back into it. That is the first condition. The second condition is you cannot move card out of cell n comma m, right? So we also have a stack at cell n comma m. This is the final stack, right? So once you move a card into the final stack, you cannot take the card back out, right? So let's say I push my card A1 into this, right? So if I push a card A1 into the final stack, I cannot move this card again, right? So now my card A1 is fixed. I cannot move card A1 again. That is the second condition. And the third condition is size of stack at any other cell than 1 1 and nm cannot be more than 1. Right? So that is the third condition. So except for cell 1 comma 1 and cell n comma m, you cannot place two cards onto the same cell, right? So if I place, let's say, card A1 here, then I cannot place card A2 here, right? Because then the size of stack will be equal to 2. But we have been told that size of stack at any other cell other than 1 comma 1 and nm cannot be more than 1, right? So at every cell there should be less than equal to 1 card, and that is the third condition. So you cannot push two cards onto a single cell. So these are the three conditions and these are the operations. So given this, we have to answer in either yes or no if we can achieve the identity permutation at cell n comma m. So let's move on to the solution, how we can solve this. You only require one observation to solve this. So the only observation that you require is observation 1. That is, you only need two free spaces to move a card from 1 comma 1 to n comma m, right? So let's say my n is equal to 4 and my m is equal to 4. So I have a grid of size 4 into 4. So something like this, right? Initially all the cards are at the first cell. So we have A1, A2, so on up to AK, right? A1, A2, A3, A4, so on up to AK. And we want to move such that the permutation formed is 1, 2, 3, 4, so on up to K, right? And we have been told that once you push a card into the final stack, you cannot take it back. So we have to first push this element K into the stack, because if you push any other element, then you cannot take it back out, right? Then your bottom element will never be K. For example, let's say you have a card 5. So if you first push this card 5 into cell n comma m, then your stack of cell n comma m will look something like this. It will look like this. You will always have 5 at the bottom. So if you push this card 5 first into the stack, 5 will always remain at the bottom. And due to the second condition, that is, you cannot move card out of cell n comma m, you will never be able to take this card 5 out of the cell n comma m, right? So your card K will never be at the bottom and you will never be able to achieve the identity permutation. So you will first try to push card K, then you will try to push card K minus 1, then you will try to push card K minus 2 and so on, right? So that is the order you will try to push the cards into cell n comma m, right? And to do that, we have been told that you only need two free spaces, right? So if there are two free spaces, you can move a card from 1 comma 1 to n comma m. So let's see how we can do this. So let's say your initial stack looks something like this: A1, A2, A3, A4, so on up to AK. And let's say your element A13 is equal to K. That is, your card K is lying on the 13th number. So if you want to move this card K from cell 1 to cell n comma m, we first have to remove the first 12 cards, right? So you first need to remove these first 12 cards, and then you can move this card K from 1 comma 1 to n comma m. And I have shown this here that you only need 2 free spaces to move from 1 comma 1 to n comma m. So let's see what this means now. So first I have to remove these first 12 cards. So let's move to the grid now and let's see how this works. So first of all, the top card is A1. So I will take A1 and move it to, let's say, the rightmost cell. So I will take A1, I will move this here, and I will then move it to the rightmost cell. So now my A1 is here. Then I will move A2 here, A3 here, A4 here, A5, A6, A7, A8, A9, A10, A11, A12. So now I have removed the first 12 cards. So if I come here, I have taken care of these 12 cards. Now my top card is K. So now I have to just move this card from 1 comma 1 to n comma m. So if I see the stack here, now my stack here will be how much? It will be K, element A14, A15, so on up to AK. Now I have to just move this card K from cell 1 comma 1 to n comma n, and there are 2 free spaces. This is the first free space and this is the second free space. I can just use these 2 spaces to move from 1 comma 1 to n comma m. So how can I do that? So first I will move the card K out. So I will take the card K, I will move it out. So now my card K is here. Then I will move it to the right cell. So now my card K is here and I will remove it from here. Right, so now it is not here. Then I will just move card A3 up, I will just move card A3 up and I will move A4 here. So now my A4 is here and now my A3 is here, right? So this cell is empty now. So now this cell is empty. Then I will move A5 here, right? So now my following cell is empty. Then I will move A1 here. Now this cell is empty, right? Now this cell is empty. Then I can just move K here. So now this cell becomes empty. Again, I can move A5. Again, I can move A5 to the top, and I can move A6 to the left side, right? So now this cell becomes empty. And now my A6 is here. And I will remove this also. So now my A6 is here. So now I can move K to the bottom. So I will move K here. And now this cell becomes empty. Right? Again, I can move A5 to the right cell. I can move A6 to the top. I can move A8 to the top. I can move A9 to the left, right? And then I can move K bottom and then I can again move K to the bottom, right? So you can see I can just use these 2 spaces to move a card from cell 1 comma 1 to cell n comma m. And that is the entire solution. The only thing left is implementation. So you just need to implement, and for every card from K, K-1, K-2 up to 1, you need to check if there are 2 empty spaces. If there are 2 empty spaces, you can move the card from 1 comma 1 to n comma m. Otherwise, it is not possible, and the answer is no, right? So if we move on to the solution, it will be something like this. For every card from K up to 1, check if 2 spaces are left. Check if 2 spaces are left. If yes, move the card. Otherwise, the answer is no. So now how do we implement this? Because I think only implementation was the tricky part in this. The observation was not that hard in itself. So let's see how we can implement this. So to implement this, I will keep some variables. I will keep a variable toMove, right? Initially it is equal to k. That is the card that I want to move. Card that I want to move. Second variable is spaces left. This is initially equal to n into m minus 2, right? That are spaces left on the board. Or you can say empty spaces left on the board. Then I have my vector visited. Visited of I is equal to 1 mean that I have seen card 1 or I have visited card 1. Right? And then I will iterate through the stack. So I know my stack is A1, A2, A3, A4, so on up to AK. So I will iterate through this. Iterate from, let's say, I from 1 to k. My card here is A of I, right? So when I see this card, I will set visited of AI is equal to 1. Now there will be two cases. Either this is the card that I want to move, either card is equal to what I want to move, or card is not what I want to move, or card is not equal to what I want to move. Or you can say this is a waste card. So if you see here, right, in the first example, I wanted to move my card K. But there were 12 cards that were before this, right? So my cards A1, A2, A3 up to A12 were waste cards. They were just wasting space, right? I wanted to move my card K, but these 12 cards were just before this and they were just wasting space, right? So if your card is not what you want to move, then it will just waste space, right? So you can do spaces left minus minus, right? Because each card will eat one space. So whenever this is a card that you don't want to move, you have to store it somewhere, right? So when you store it, it will eat one space. So you can do spaces left minus minus. And the second case is when it is the card that you want to move. If it is a card that you want to move, you will just check if there is enough space to move it. That is, if spaces left is greater than equal to 2. If it is, then you will just move this card, or you will do toMove minus minus, right? Because if there is enough space, if your toMove was initially, let's say, equal to k, if there is enough space, you will move this card k, and now you want to move card k minus 1, right? Because if you move card k, the card that you want to move is card k minus 1. So you will do toMove minus minus. And if there is not enough space to move this card, you can just print no, else the answer is no, right? Also, one more thing that you guys need to take care of is that when you set your toMove equal to, let's say, k minus 1, now there might be a chance that this k minus 1 was among the first 12 cards, right? So you have A1, A2, A3, so on up to A12. Your A13 was equal to k, right? This was initially your toMove. So when you come to this card, you will see, yeah, I can move k. You will move this k and you will set your toMove equal to k minus 1. But there might be a chance that this value k minus 1 was lying in the first 12 cells. It was lying in the first 12 cells. So here you will also keep one more while loop. So you will check while visited of toMove. You will do toMove minus minus, and you will do spaces left plus plus, right? So you will do a while loop and you will check while toMove is lying in the first cards. While it is lying in the first cards, you will reduce toMove minus minus, and you will move the card to cell n comma m. And when you move that card to cell n comma m, it will free up a space, right? So you will do spaces left plus plus, right? For example, I will make a new grid to explain it better. Let's say I have a new grid. So there are 12 cards here. This is A1, this is A2, this is A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, right? So I will move this card K. So now my card K is on top here. So I will move this card K to cell n comma m, right? So initially my to move was equal to K. So I moved K from 1 comma 1 to n comma m. So now my K is here, right? Now my to move is equal to K minus 1, right? So let's say your A3 is equal to K minus 1. Your A3 is equal to K minus 1. So my this value is equal to K minus 1. So now I can easily move this value A3 to cell n comma m. So I will move this A3 to cell n comma m. And now this cell is empty, right? This cell is now empty. So I will do spaces left plus plus, and I will do to move minus minus. Now I want to move my card K minus 2. So I will again check if my K minus 2 is among these cards. If it is not, then I will iterate over the stack again, right? And that is the entire solution. So if you guys want to see the code for this, here is the code. So here are the variables nm and k. Initially, to move is equal to k, spaces left are equal to n into m minus 2. So I will take in the stack and I will iterate over the stack, and I will set visited of vi is equal to 1. If this is the card that I want to move, I will check if spaces left are greater than equal to 2, right? If there is enough space, I will remove this card and I will do to move minus minus. Then I will check the cards that I have left over. If my to move is among those cards, I will do spaces left plus plus and to move minus minus. Otherwise, if there is not enough space, the answer is false. So I will just return false. Otherwise, if this is not the card that I want to move, then it will just waste space. So I will do spaces left minus minus, right? And in the end, I will just return true if all the cards can be moved. So that is the entire solution. And if you guys have some doubt, feel free to join my Discord server. I will be more than happy to answer your doubts there. I will leave a link to that in the comments. And yeah, that was it for the video, and I will see you guys in the next one. Bye bye.